Now that we've done a quick review of arrays, let's talk about the Arrays API that's included in the Java JDK. The Arrays API can be used if you include the java.util.arrays at the top of your program. It contains many useful array methods. Some of the methods include search methods, comparison methods, fill methods, copy methods, and sort methods. Let's take a look at a program that uses some of these. I have a program called Sample APIs. On line 14, 15, 16, and 17, I declare a few arrays. One's an integer array called numbers that just has some random numbers. Then I have a character array that lists all the vowels. Notice, since it's a character array, the vowels all have single quotes around them. And then I have two Boolean arrays that contain some Boolean values such as true, false, false, true, true. I know in many programming problems you have to try and find a value in an array. You want to search for it. A pretty efficient search is called the binary search, but a binary search requires that the array is already in sorted order. But lucky for us, one of the static methods in the Arrays API is a sort method. So on line 19, I print out the array numbers prior to sorting. Then on line 20, I use the sort method to sort the numbers array. Notice the way that I had to set this up. Since the method is a static method, the first thing I have to do is specify the class name. The class is called arrays.sort, and then in parentheses, I give it the variable for the array that I want to sort. So I'm sorting numbers, and then I'm going to print them back out again. This sort method works with arrays of type int, double, character, byte, long, short, and even objects. The next thing I wanted to show you in my program is how to use that sorted array and perform a binary search. A binary search is used to find a specific value in an array. So you need to first identify what is the value you're looking for. On line 25, I have int key equals 25. On line 26, I'm going to use the static method binary search to look for that key in my numbers array. So I have int key position because the binary search method returns the integer value of the location of the key that I'm looking for. So I have int key position equals arrays, the class name, dot binary search. In parentheses, I give it the numbers array and the key value that I'm looking for. This binary search works with arrays of types int, double, character, byte, long, short, and object. But remember, a binary search only works if the array is already sorted. On line 28, I print out where the key was found in the array. On line 30, I wanted to show you how to use the static method equals. This method allows us to compare any two arrays to see if they are equal. So I have if arrays.equals, and in parentheses, I give it the two arrays. In this case, I'm going to pass the two Boolean arrays that I created. Notice that the values are not the same. Each array has all the same values, but they're not in the same order. So on line 30, we're going to use the equals method to compare those two arrays. If they're equal, then it'll print out a message saying they are the same. Otherwise, it'll print out they are different. And the very last method I wanted to show you was how to use the copyOf method. If I wanted to make a copy of the numbers array and maybe double the size, because arrays are a static size, I can create a second array called numbers2. So on line 36, I have int bracket bracket numbers2 equals arrays.copyOf. I give it the array that I want to copy, numbers, and I give it the length of the new array. So I went ahead and took the length of the first array, numbers.length, times 2. So that will actually give me an array that is 2 times the size of my original array. Okay, let's run this program to see what's happening. You can see before the sorting method is called, the numbers are out of order. After we called the sorting method, they're in order, and then my key was found in position 5. So let's count. The value 3 is in position 0. Remember, all arrays start with 0. The value 4 is in 1, 5 is in 2, 12 is in position 3, 17 would be in position 4, and 25 is in position 5. Awesome. Well, that sure made my life a lot easier, being able to use that binary search. And the last thing is the two Boolean arrays are different, and that's because the second Boolean array has the first two values reversed. It has false true instead of true false. Make sure you take some time to look at the Arrays API. I think you'll find that a lot of those methods will really come in handy.